Let's move on to the cytoskeleton. Do you remember the cytoskeletal elements? We've got microtubules, actin, and intermediate filaments. We call it the cytoskeleton, but it's not just to hold the structure of the cell. It also has roles in transporting things around the cell along microtubules, helping the cell move around using flagella, and even helping the whole body move, since muscle contraction depends on actin and myosin. You can get a sense of how the cytoskeleton is organized by this picture, where the nuclei are blue, the microtubules are green, and actin is red. Actin and myosin compose microfilaments and are the thinnest structure in the cytoskeleton, with a diameter of just 7 nanometers. You probably know that actin and myosin work together in muscle contraction, and that's covered in a different lecture. But can you think of anything else that actin does? It's an important structural component in microvilli. Do you remember where you might find lots of microvilli? One example is the brush border of the small intestine, where microvilli are used to increase surface area and therefore increase absorption. Remember, a villus has a lot of cells, and each cell has lots of microvilli, so microvilli are a lot smaller than a villus. Actin is also used in adherens junctions, which are common in epithelial and endothelial cells, and are used to hold cells together. Intermediate filaments are generally involved in cell structure and have an intermediate diameter of about 10 nanometers. Some examples of intermediate filaments are vimentin, desmin, cytokeratin, glial fibrillary acid proteins, and neurofilaments, but I'll come back to these in a couple minutes. And microtubules are the largest part of the cytoskeleton, with a diameter of about 25 nanometers, and they're generally involved in movement of things within the cell, or of the cells themselves. We see them in cilia and flagella, and also in the mitotic spindle and centrioles.